Hi, my name is Alusain Barry. Welcome to this further mathematics video on calculus, the product rule for differentiation. My name is Alusain Barry. Today we are going to do one example of application of the product rule. Okay, so we solved quite some examples earlier, and in this video we are going to solve this second problem Roman number 2. Okay, we are asked to differentiate the function with respect to x. As we can see with many of these functions we have here, all of them, they are all products. Okay, it's all you see. For example, here we have x plus 1 multiplied by x squared minus 2x plus 1. Okay, let's just take some space so we can do our work. Okay, so we have here the problem Roman number 2 says x plus 1 bracket open x squared minus 2x plus 2. Okay, now remember there is not a multiplication sign here, but the bracket tells you that there is multiplication. So we are multiplying this function and this function. We are trying to find the derivative. Okay, first of all, we can assume here, say y is equal to, given this, it implies, although it's not stated that y equals to it, we know that this function is going to represent the behavior of some independent variable. Okay, it's going to influence it. So we have uv, okay, where it just means the two functions have been multiplied, uv. Okay, sorry, uv, okay, where u is x plus 1, okay, and v is x squared minus 2x plus 2. Now, note that, note that according to the product rule for differentiation, to the product rule, if we have such a function, let me buy some space. According to the product rule, the derivative of a function which is a product of two functions is dy dx, the derivative of the differential coefficient. We hold this and then we multiply it by the derivative of the first one, which is u here, du dx with respect to x. Okay, plus we hold the second function the first one u, and we multiply by the derivative of the second function v with respect to x, dv dx. Okay, so this is the product rule. Now we now know what v is. We know what v is. We know what u is. Okay, x plus 1 and v, x squared minus 2x plus 1. But we do not have du dx and dv dx, so we say du dx, which is the derivative of u with respect to x. This is just 1. Remember, a derivative of a constant is just 0. Okay, and the derivative of x, you can imagine here being 1, and we multiply by everything and we subtract by 1. 1 minus 1 is 0. X raised to the power 0 is 1. Okay, so 1 times 1 is just 1. So du dx is 1, and we find dv dx is equal to, now of course for this we multiply the expression, the term, by 2, and then we subtract 1. Okay, so the expression x here multiplied by 2 is 2x. 2 minus 1 for the power is just 1. Okay, it's just 1. 2x raised to the power 1 minus here again, you can imagine we say we have 1 on top. If there is nothing on top of a term, we assume there is always 1. Okay, so we can multiply the term by 1. 1 times 2 is just 2. Okay, and then x, because 1 minus 1 is going to be 0, x raised to the power 0 is just 1, so 2 times 1, which is just 2. Right, so we can just, the dv dx is just 2x minus 2. Right, so we say now we can, let's buy more space. We say hence dy dx is now equal to, what is v? We have v as v as x squared, v as x squared. Remember, we say v here and then we multiply by the derivative of du dx here, which is 1. So, and if you multiply v, which is x squared minus 2x plus 2 by 1, is just going to be that. Okay, so we are multiplying this by 1. All right, let's just put the brackets, and then plus, with the plus sign here, u now, what is u? U is x plus 1, remember? So we have x plus 1 multiplied by the derivative of dv dx. What's dv dx? We found it to be 2x minus 2. 2x minus 2. Okay, now we can try and simplify this a bit further. We say, now of course this expression multiplied by 1 is just that expression, x squared minus 2x plus 2. Okay, plus, now for this here we can multiply out and say each term of the first, when you are trying to expand the bracket, you multiply each term in the first bracket by each term in the second bracket. Okay, so we are going to multiply x by 2x and x by minus 2. We do the same for 1. Okay, so x times 2x is going to be 2x squared, because x times x is x squared. Okay, and then we say x times minus 2 is going to be, so plus times minus is minus, so x times 2 is just 2x. Okay, and then we do the same thing for 1. 1 times 2x is going to be plus 2x, and 1 plus 1 times minus 2 is plus times minus is going to be minus. 1 times 2 is going to be 2. Right, so now let's see how we can, if there's anything we can cancel out here. Minus 2x can cancel out plus 2x. Okay, because this is just like adding one bread and then taking one bread, is just 0. Okay, so we have here plus 2 and minus 2 here, they also cancel each other out. Let's see anything else here, and we have x squared, and we have 1x squared here and another 2x squared here. So 1x squared and 2x x's squared is going to give us 3x's squared. Okay, yeah, and then we have minus 2x. Okay, so let's check this actually. X squared minus 2x, this is gone. Yes, this was what we added, so this is our derivative. Okay, so we say therefore dy dx is equal to 3x squared minus 2x. Okay, thank you.